Hi everyone! Today we're going to be working on a super awesome project. Check it out. Ooh. I've hacked an IKEA lamp with the RGB NeoPixel patterns that we learned about earlier. And the best part is, it's running on an ESP32 and it's totally over Wi-Fi. No wires. Check it out. It's like an IoT light. So I hope you're excited because we're going to jump right into it. First, let's take a look at the hardware. This is an ESP32 or Huzzah 32 from Adafruit. It's the Feather edition. I believe they literally just released a new version of this, so that's pretty awesome, but I have the older one. And then as per the recommendation, I connected this ginormous capacitor across the power and ground for the NeoPixels, as well as this resistor down here in series with the data line so that to protect the data line basically. Out of that, I've got two different, let me focus that in there, two different sets of 3-wire cables, and you can just get these on Amazon, and I'll link all the hardware in the description. This is what clips into the actual LED strips that you can also get from Amazon or from anywhere that you get your NeoPixel LED strips. On the flip side, and this is usually optional, but I decided to just play it safe, I've soldered on a, let's try that, whoops. Try to tap the component to focus it. That's hilarious. Okay, it's a logic level shifter. You can't quite see the part number right there, but I will link it below. Basically what that does is it shifts the logic level of the data line from 3.3 to 5 volts. It's not strictly necessary because for the most part, most projects do work without it. But it's just, technically not within the specification of NeoPixels to be driven by a 3.3 volt data line. And so I just decided to go ahead and connect that up, and it was quite a task. Look at that crazy cowboy soldering there, geez. But anyway, it works. And now let's take a look at the lamp side. Ooh, what's behind the curtains over here? Oh my goodness. All right. So IKEA would have me usually put light bulbs there, which I did, but I also took an LED strip on either side. So one on this side, one on the opposite side. And it goes up all the way to the top. There's 75 pixels on each strip, so 150 pixels total being driven by this microcontroller. And so what you have to be careful of is the power draw, right? Like in theory, each pixel would be on average around 20 milliamps or 30 milliamps. And so if you have 150 pixels, that is starting to get into the amps range for power. So what you do want to be careful of is to get a power brick for your USB. So your USB that powers the microcontroller there. In this case, I've got like a big honking power brick over there. That one can actually handle up to 3 amps, so I played it a bit safe, and that makes sure that you're able to get a steady supply of current to all your lights. And then just to show you the connections, so I soldered on these, or actually no, Natalie soldered these on, my partner soldered on these connectors. So this is like the opposite side, the plug side of the connectors that I showed you earlier from the ESP32. And the other one's hidden in there somewhere. Oh, yeah. So now that we've seen how the hardware works, let's look at the software side. So as before, we're going to be controlling NeoPixels, and this time we're going to use the built-in NeoPixel library that's already there in MicroPython, which is awesome. Here's the documentation for it, and it says it's for ESP8266, but it works just fine for ESP32 as well. It's the exact same. The library is pretty easy to use. We just have to import NeoPixel, create a NeoPixel object with the machine library using the pin number that you particularly connected to in your setup. And then we just assign it, like as if it's a list, we assign a color tuple, so that would be RGB, and we just keep going down the list. So in our case, in this setup, there's 75 NeoPixels, right? So like this list will have 75 entries in it, and each one can be a tuple of whatever color we want. So let's just try setting that up with a very simple color. We're gonna open up our Thonny IDE, which I do not have here. And we're gonna want to connect to that thing, but just so because it's so pretty, I'm gonna leave it on for a couple of seconds while we write some code over here. So we're gonna import our NeoPixel library. And we're gonna import pin from machine. And we don't need time or anything for now. We'll need it eventually, but I'll just leave that for now. And what we want to do is just do some setup. So let's assign our LED pin. In this case, I used pin number 21. The number of LEDs, in my case, is 75. So actually it's 150 LEDs, right? So you might be confused, like, why am I writing 75? It's because I made those two strips connect in parallel. So if I change the color on pixel number 0, let's say, that actually changes pixel 0 on both strips at the same time. So it's really just 75 from the software point of view. And lastly, let's create our pixels object. So let's say equals Neopixel. Oh, whoops, almost forgot that. Capital P, it's two different words. Okay, Neopixel pin, and we give our LED pin number in this case, and the number of LEDs, so it knows what to do. Okay, and then next, let's just start off by doing something super simple, which is setting a color on it, like any color. And to do that, let's create it as a function so that we can actually keep changing it again and again on the REPL. So let's say we have, let's call it set RGB color. So let's create a function set RGB, and it takes an R, a G, and a B, and we just go over all the LEDs or all the pixels. Let's say pixels I equals RGB. Oh God, sorry. And we just want to write that. So yeah, always, this is something I always forget to do. Pixels are right, so this actually sends a signal. Like, this is just putting stuff into a list. It's not doing anything. This is where we actually send the signal down to the NeoPixel chip, driver chip. Okay, cool. Let's try it out. Unfortunately, this means I gotta go unplug it, which is so sad, but let's do it. And I'm gonna plug this into my computer. So now we're gonna get power from the computer, but also we get a serial line to talk to over it. Awesome. Let's save this as main.py, and I'm just gonna save it there for now. So that's just saved on my computer now. So it says down here, can't find device automatically. I think to refresh it, you usually just have to press restart backend there. And there you go, it's found our ESP32, fantastic. So we are going to try it out. Let's import main, and then main.set RGB. Let's try red. Aha, it has no attribute set RGB. It's not the first time I dealt with this. That makes sense. I actually did not save it on the microcontroller yet, so what I need to do is save it on MicroPython device as main.py. Let's overwrite it. Cool. And actually a trick I learned in order to restart, like fully restart your microcontroller, is you can do a machine.reset. So that does a hard reset rather than a soft reboot, which is when you press Control D in your REPL, it just does a soft reboot. If you want to do a hard reboot, start all over again, you do machine.reset. Okay, wow, words, numbers, okay, cool. Import main.set RGB, and let's try red. So that's 255.0.0. Woo, awesome, okay. And let's just try them all, see what happens. It's white, pearly white. Let's try yellow and purple. Fantastic. Okay, so that's working, but that's super easy, right? And actually, when we want to do advanced patterns with RGBs, we want to be able to fade between all the colors, right? And so, as we've seen before, RGB is not very conducive to that. it's not very easy to fade different colors in RGB. It's actually easier to use hue saturation value, and I've written a whole tutorial on it, which you can check out if you want to understand really like what does that mean. So let's say MicroPython Neopixels. Ha. So this one. So if you don't know what I mean when I say hue saturation value, I'm really talking about this here. So do check out my tutorial and you'll understand deeply like what I mean and how the system is used. I just don't want to get too much into that today because I've already explained it before. And so what we need to do is we need to bring in a function that can convert hue saturation and value to RGB values. Luckily, the same NeoPixel library that I used before actually has that function. And just because we don't really need the entire library, we just need that for one function, I'm just going to go to their GitHub page and pull it. So it was, I believe, GitHub, and then blaz-r and PyPico NeoPixel, right? We're going to go into the code there, and there's a lot of Raspberry Pi Pico specific code. We just need something that can take an hue saturation value and spit out an RGB. So here we go. I'm just going to copy that. Notice that it returns RGB as 3 separate values. We actually wanted to return a tuple. So I'm just going to put brackets around it in our code. So takes HSV, returns RGB. Fantastic. Oh, didn't get the B there. Okay. And we're going to return that as a tuple so that it's useful over here. So let's try using that. What we're going to do is we can, we don't need the self either. So it's not a class method anymore. It's just a function, right? Let's try it so that we'll run set RGB, and instead of giving our own RGB values, we'll feed in a color HSV, and we'll feed our HSV values. Oh, and I almost forgot one thing. Before we do that, if you want to pass in a tuple, we actually need to expect one over here. So let's just call that RGB tuple, 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 tuple. And we're going to say, just going to replace that. So that should work. And let's save it over here. We need to do a reset so we get access to the new code. The thing is, what happens in Python, the reason I keep resetting is when you import a module such as import main, the second time you do an import main, it just uses the cached version of that you already previously had. So even if it's changed on the file system, it doesn't change over here. So this is the quickest way I've found so far to deal with that. Maybe there's a faster way and we can try that. For now, I'm just going to import main. And then main.set RGB, main.color HSV. And what color should we try? We can try, let's try something like a nice green. So that's 25,000, and then full saturation, full brightness. Aha, that's really nice. It's like minty fresh. Okay, awesome. So that works. So we're able to create RGB values from HSV values and then pass them in. Now let's have too much fun and try to make this pattern that I like to call Niagara, like based on Niagara Falls. If you've ever been to the Canadian side of Niagara Falls at night, they light up the entire waterfall with like these amazing RGB candy colors, and it's just such a great time, especially when you're having a lot of fun with your friends, right? And it's just so colorful. It's awesome. So we're gonna actually try to replicate that today. Let's try, so let's call that candy unicorn rainbow, aka Niagara Falls. So I'm just gonna call that Niagara, and it's going to take, so it's gonna cycle through all the colors, really all the hues. The main parameters maybe we want to play with are saturation and brightness so that we can just adjust kind of how it looks, right? So I'm just going to say sat and give it a default value of 255 if you don't feel like customizing everything, and a value of also 255. And what we're going to do here, so we're going to use a similar code that I've taught before in Neopixels, which is start at a hue of 0 and then cycle through all of them. So hue goes from 0 to 65,535. The reason I remember that number is because I've been coding for so long that it's kind of etched in my memory. But let's start with 0, which is red. And we're going to have a while true loop. So we're just going to constantly be displaying these patterns. While true for every pixel. So in range num LEDs, as we had before, same as up here. Instead of assigning it a static color, so we're going to say, we're going to assign it a hue saturation value based color. So we're going to go hue saturation value. And what we want to do is, so this is just setting the, let's say it's setting the very first pixel, like pixel number 0 at the bottom. What we want to do is the next pixel should be a color offset from the previous one. And then the next pixel after that is offset again, and so on and so forth. And how much is that offset though? Like, we should try to calculate that. And what I really want is there to be like one spectrum on the entire pillar at any given time. And so really what we want to divide that entire hue domain, 65,535, divided by 75, so that we can get the offset of how different each pixel should be from the previous one. And so I'm just going to say hue equals now hue plus 65,535 integer divided by 75. So that, this is very important. If you don't do this, like, so double slash in Python means integer division, so it'll spit out a whole number. Otherwise you'd spit out a fractional number, and that doesn't really make sense for hue. So you just need to make sure of this. And then we're gonna modulo that with 65536. So in case the number, in case the hue number overflows, that goes over 65535, it'll wrap around back to 0. So you have red again at the bottom. So that's what you need to do. And you need to do this again. So this is interesting. So this one is for each pixel. So to offset each pixel from the other one, right? What we also want to do is, at Niagara Falls at least, they have the lights like kind of smoothly going over the falls. So like the red moves and then the blue moves along after it. So if you want all the colors to move down, oops, to move down this thing, we also want to do the same thing. So we want to say the starting hue itself should move over time. So again, I'm going to say hue. Actually, I can just copy this. Aha. So that's good. So that's the pattern. Don't forget your pixels are right, because I always forget that. Pixels are right. And we want this to occur at a certain rate. And you know what? Maybe we can even make that a parameter, because then we can play around with how fast or slow it is. So let's just say delay millisecond and give it a default value of 50 milliseconds. But we can specify a faster or slower one if you want. So we're going to say time dot sleep millisecond. We're going to say delay millisecond. Almost don't forget to import the time library. So here it is, import time. And we have it down here. Perfect. I'm going to save that on the microcontroller. I wonder if it's possible to re-import main by deleting our reference to it. So let's try that. Delete main, import main. Let's see what happens. I don't know if this works. Okay, no, it doesn't work. So we do have to do the machine reset. So we're going from machine import reset and then reset. Fantastic. Okay, so let's say import main.Niagara. Please, 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 yes. Oh, look at that. That's amazing. Okay, and since this is a while loop, it's actually just going to loop forever. So if you want to break out of it, just Control-C, like as you would do in other Python programs. Let's try playing with the parameters. So let's say main.Niagara, and let's reduce the brightness so maybe you can see it better. So actually saturation first. So let's make it more candy, like less saturated. Brightness down, like really low. Let's try that out. Ooh. much easier on the eyes and more candy-like. Let's try playing with the speed. So we had 50 milliseconds there, right? Like what if we had, ooh, like something really fast, like maybe like 20 milliseconds. How fast would that be? Huh. It doesn't seem to change that much. And what about if we made it really slow? Oh yeah, that is slow. That is so slow. It's like a lava lamp, like a rainbow lava lamp. Okay, so that's really fun. What could be even more fun is, so we already have this. What if we could do all of this without all these wires? Like what? This is kind of crazy. Like my computer is connected to these Neopixels right now, but I want to connect it to the wall and control it over Wi-Fi, right? So let's get into the Wi-Fi part of all this. So you remember last time we connected Wi-Fi in the main file itself? Well, it turns out there's a better practice to do it. You can actually do it in boot.py. Every microcontroller that runs MicroPython has a file called boot.py. Okay, so let's open up boot.py. It's on the MicroPython device, and we have it there. Boot.py, okay. It's doing absolutely nothing right now because everything is commented. What we want to actually do is we want to enable something called WebREPL. And what WebREPL is like, you know how we have the REPL down here, which I'm controlling over the serial port, and I can type in stuff. We can actually do that over the web. That's pretty cool because one, you can trigger some code changes. You can like start your colorful LED function, but also it gives you the ability to update files on the fly. So say you have main.py, you want to add a new pattern to it, you can write your own main.py on your computer and then just like send it to the microcontroller, and then now it has that new capability. So it's kind of like a over-the-air update of your particular code, which is so awesome, and it's just built in with MicroPython. So to get WebREPL working, we need to run a WebREPL setup function, and that is documented somewhere. Let's look it up. MicroPython WebREPL. Nope. Aha, you have to run import WebREPL.setup, and that will set it up for you. So import WebREPL, _ setup. Aha. Would you like to enable or disable it running on boot? I'm just gonna say enable. Would you like to change the WebREPL password? I've already set my password, so I'm just not gonna change it. You can set whatever password you like. Would you like to reboot now? Let's do it. Okay, so you can see it did a machine reset over there. And let's open boot.py. It shows as if it's not updated, but I'm pretty sure it has been updated. Huh, I guess not. Okay, so what you want to do in boot.py is you want to go in and you want to uncomment these lines. So now you have the ability to have WebREPL on startup. But also in addition, we want to connect to Wi-Fi, right? So like the WebREPL is not very useful if you don't have Wi-Fi. So what we're going to do is we are going to import. We want our Wi-Fi username and password. As I showed you last time, we want to put that in a separate file called secrets.py. So what you want to do is, let me show you that. I'm not going to open the file, but I have a file called secrets.py over there. And all it has in there is it has two variables. One is called SSID, and that is blah, blah, blah. And then one is called password, and that is blah, blah, blah. Or I believe I call them something nicer, like Wi-Fi name and Wi-Fi pass. So just make a file like that, store it on your microcontroller so that you can grab your secrets from there, but not share them with anyone else. What we're going to do is write a quick connect function. So we're going to say connect, and we're going to import network in here. We have our station interface, and we're going to make that a wireless LAN connection or Wi-Fi connection of the type station interface. And if it is not connected, so this is really nice. If it's not connected, only then we try to connect. Otherwise, the microcontroller tends to freak out and complain every time you restart your code, right? So if it's not connected, you're going to say, you're going to set it to active, and you're going to connect. And this is all kind of boilerplate code. Like I'll link it down in the description there. I got all this from the documentation for connecting in your boot.py. And last one, this is pretty important. We want to actually print our network configuration so that we know what is the IP address of the microcontroller, and then we can connect to it. So I'm going to say network configuration, and from our station interface, we can actually get our interface configuration. Cool. That's that. Then after all this, actually, I prefer to connect first. So let's connect on boot, and then let's do WebREPL.start. So we wrote a function to connect to Wi-Fi using our secret username and password, and then we start the WebREPL. So let's try that. And actually, this should just work right now. Like we should be able to log in from the WebREPL interface, which I'll show you soon. So I've just saved that. I'm going to restart. And reset. There seems to be an error. Wi-Fi name isn't defined. Of course it's not. Because I didn't import it. Who would have thought? Save that. Okay, WebREPL daemon started on thingy, network config. Wait a second. That's not an IP address. Okay, so we actually, what's probably happening is at this point when we set it to connect, and then we print out the network configuration right after, it's probably not connected yet by this point, right? There's no way that it connected in like a millisecond. So maybe let's create a separate function to show the IP address. So show IP address, and it's basically the same code as the bottom over here. So we're gonna say, we're just gonna copy it. So we're gonna grab our station interface, and we're gonna print the network configuration. Okay, so what we just need to do is like wait a couple of seconds and then show the IP address. So let's do that. Okay, so again, we didn't really get a network configuration, but what we can do is from boot, import show IP. Oh, it just ran the function. I guess that's how that works. Okay, so yeah, this is the IP address for me. It's going to be different for you. These are all different parameters of the network. So this is the subnet mask, and that's the default gateway, and that's something else. I don't know. Anyway, we only care about the IP address here because that's what we need to use in a WebREPL. To use WebREPL, what you need to do is go to the GitHub repository. So you're going to go micropython/WebREPL. Pretty simple. Clone the repo to your drive. So I've already done that, and I have MicroPython web. Oh, do I really? Oh yeah, just call WebREPL. And in here we have a bunch of stuff, but we just need the WebREPL.html. So just literally open the HTML file. That's it. That's the entire thing. That's crazy. What we're gonna do is I'm going to show that. WebREPL.html. Cool. Here we are. So you see over here, the interface allows you to connect to a thingy, and then on this side, you can send files or get files. And I'm just going to zoom that in to make it easier to look at. I'm going to put in my IP address from before that I saw down here in the Thonny terminal, 1.198. And the port number is 8266, which is cheeky because ESP3266, haha. All right, let's connect. Welcome to MicroPython. Password. Let's go put my password in. Okay, what? It's not working. What's going on? Okay, actually, it took me like ages to figure out what's going on here. So you can't actually have two REPLs running at the same time, and I have one running over here, right? That's the issue. So what I need to do is to disconnect this one somehow. Does that work? No, it doesn't. How do I close this? I don't want the shell. Oh, no, bye-bye shell. Go away. Okay, how about now? Let's connect. Nope, still active in the background, I think. Yeah. Maybe the best way to do this is just to, I'll unplug the USB cable and I'll just plug it back into the wall. Let's try that. So, bye-bye. Okay, it's plugged into the wall. Let's see if it automatically connected on startup as we want it to. So connect. Aha, it did. I am accessing it. Whoa! WebSockets. Amazing. Yeah, the way WebREPL works is basically we create a WebSocket connection. So that's why you see the URL for it is WS WebSocket. And everything you type is kind of returned by the terminal, and then it's similar to kind of a serial terminal, but over the web. So what we can do here is we can try to see if our code runs, right? So it's a import main dot set RGB. Yeah, let's set it to red. Oh, right, we changed the way the function was defined, right? It takes a tuple now, so we can just put another bracket around that. Aha! Over the web, no wires. Amazing. This is crazy. And now what we can do actually is we can even add more stuff in, right? So that's what I was talking about, the send file feature. So let's say we write a silly function called, so let's save that on my computer just so I don't lose it. Yeah, replace that. So just to like illustrate the point, right? Let's write a function called blue. And all this does is it sets the lights to blue, right? It's kind of dumb, but let's just do that. So let's say, let's copy that code. Pixels I equals RG blue. And then just write that, okay? So the point is that, this is a silly example, but the idea being that you can write any new pattern. So say you're tired of the Niagara pattern, you want to make a lava lamp pattern, or you want to make another unicorn pixel pattern or waterfall or whatever. You can update the code live over Wi-Fi. So I'm going to save that file and I'm going to go over here, send a file, click choose file. Is this the correct one? No, it's not. What about it? Where's my stuff? Okay, there it is. Cool. So it tells you what size it is, 1758 bytes. You can say send to device, send main.py 1758 bytes. Awesome. Let us reset. So we can even reset over the air, which is cool. Okay, we lost the connection, obviously. So because we reset the machine, haha, who would have thought? Okay, and then now let's wait a few seconds, connect again, put in your password, import main, and let's run main.blue. I'm blue, da ba dee ba da ba da ba da bee ba da ba. Okay, awesome. That's the entire tutorial. You learned how to set NeoPixels on real NeoPixels. You learned how to use WebREPL to upload new code and to diagnose and debug your code remotely. And you learned how to use machine.reset to quickly reset your microcontroller so that you don't have to keep pulling out your USB cable from down there. I really hope you enjoyed it. I really hope you try to make this project at home or something similar and share with us what you've done with it. I'm super excited to see what you come up with. Oh, and I almost forgot. Please do check out my website, bhave.sh. I'll link it below just so that you can see the NeoPixels tutorials I put up earlier. They're super helpful in understanding the fundamental concepts behind this. And if you follow there, you get to get updated whenever I release a new tutorial. If you prefer just the videos, you can just subscribe here on YouTube instead, or you can do both, up to you. It really helps support me and reach out to more programmers, engineers, and nerds like yourself. So please do share and subscribe, and see you next time. Thank you.